Today I want to discuss some classical mechanics formulae. Let's start it. Lagrangian. Lagrangian is the difference of kinetic energy and potential energy. T represents kinetic energy, V represents potential energy. Action. Action is the integration of the Lagrangian with respect to time having limit t1 to t2. Conjugate momentum. It is defined as derivative of Lagrangian with respect to the coordinate. Often we will encounter the term cyclic coordinate. It is the coordinate which is absent in the Lagrangian. The corresponding momentum will be conserved. Equation of motion. Suppose we take a Lagrangian L and another Lagrangian L plus df dt. These two Lagrangians will give me same equation of motions. Hamiltonian. Hamiltonian is the sum of kinetic energy and potential energy. Look, if I have Hamiltonian, I want to convert it to Lagrangian or vice versa. How will I do it? Hamiltonian is equal to sum over k qk dot pk minus L. Using this formula, we can convert Hamiltonian to Lagrangian or Lagrangian to Hamiltonian. Hamilton's equation of motion. It is known as q dot equal to del h by del p, p dot equal to minus del h del q. Poisson bracket is a very important tool in classical mechanics. In quantum mechanics, we have the same type of thing known as commutator bracket. Look, if I have two dynamical variables f and g, I want to find their Poisson bracket. It is defined as sum over k del f qk del g pk minus del f pk del g qk. There is a very important formula. Total derivative of f equal to Poisson bracket of f with Hamiltonian plus partial derivative of f with respect to t. If f has no explicit dependence on time, for finding the constant of motion, del f dt should be 0, which implies Poisson bracket of f with h will be equal to 0. Now I want to discuss some basic properties of Poisson bracket. A Poisson bracket will be 0. A alpha, where alpha is a constant, it will also give me 0. A Poisson bracket with b plus c will be simply A Poisson bracket with b plus A Poisson bracket with c. A Poisson bracket with bc will be A Poisson bracket with b multiplied by c plus b Poisson bracket A with c. Look, if c is in this position, we'll write it here only, and b is in this position, we'll write it before the Poisson bracket. For classical case it will not matter, but in case of quantum it will matter. Jacobi's identity. A Poisson bracket with b comma c plus b Poisson bracket with c comma a plus Poisson bracket of c with Poisson bracket of a comma b will give me 0. Look, there is a cyclic sequence. Next we move on to canonical transformation. Suppose we have old set of coordinates q and corresponding momentum p. We go to new set of coordinates q and their corresponding momentum capital P. Their Poisson bracket will remain invariant. Poisson bracket of capital Q, capital P will be 1. This condition will imply canonical transformation.